Okay, welcome. Today we'll be looking at the shortest distance between two lines. In my previous video, we derived a formula for the distance between a point and a line. But now we'll move it to distance between two lines. But we still need the knowledge of that distance between a point and a line. Because we know that lines are made up of points. A line is a collection of or locus of points. So what I have to do is to first draw a diagram. So we now have two lines. And I've said that previously, the distance, the shortest distance is always the perpendicular distance between two points or two lines, or a point and a line. So the shortest distance is always the perpendicular distance. So our main aim is to get a formula for D. And from our previous knowledge, we know that the distance between a point, maybe let's call it A, with coordinate x1, y1. I've done it in my previous video. And a line ax plus by plus c is equal to 0 is equal to d, that's the distance, equal to the absolute of ax1 plus by1 plus c over the square root of the sum of the squares of a and b. So as you can see, once you substitute this x1 and y1 in this, the absolute over the square root of the sum of the squares of a and b. So let's extend it to here. So we know that I will use the origin here as the point. So if I can compare the point, that's the origin, with this line, the first line, and also compare the origin and the second line, we now find the difference. That's what we are now looking for. So if we join the origin to the first line and also to the second line, I would now find their difference. That's our answer. So okay, let's join. So if we join, yes, so the notable point here is the origin. You know it is always a notable point in a plane, that in a rectangular plane. The origin, very special. So we can now find the distance. Once we know the distance from this origin to the first one, and the distance from here to here, we subtract. That gives us this. So if we call from, or maybe if we call this A, y this is B, this is O, with the coordinate 0, 0, that's the origin. So let's call it O. So if you call OA to be maybe D1 and OB to be D2, you can see that D is now the distance, the difference between D2 and D1. So using this formula now, so we are using the point and this line first, after the point and the second line. As you can see, the two lines must be parallel. That's why A, B are the same. They define the constant. So from here you see that D1 is equal to, using this formula, that's the distance, our point is 0, 0. That's x1, y1 is 0, 0. Why the line is this? So the distance is now a times 0 plus b times 0 plus c 1 over square root a squared plus b squared, which is now c1 over square root a squared plus b squared. Y d2 that same way is now a. We are comparing this point and the second line, which is a times 0 plus b times 0 plus c2 over a square plus b square, which is now c2 over a squared plus b squared. Looking for, which is now, as you can see, the difference between d2 and d1 is now equal to d2 minus d1, which is absolute c2 over this minus absolute c1 over that, which is the same as absolute c2 minus c1 over that, a square root of a squared. So it's very, very simple. Example, if someone asks you to find the shortest distance between maybe x minus y plus 7 equal to 0 and x minus y is equal to 3. So without wasting time, the answer, the distance is now, as you can see, this comes over, so it's now 7 minus, so it's now absolute 7 minus, this will come over to be minus. It must be in terms of, you must leave it in this form, equal to 0, equal to 0. So you first move before you know how you subtract. So the difference between their constants, which is 7 minus 3 over square root of 1 squared plus minus 1 squared, which is absolute 10 over root 2, which is 10 on 5 times root 2 over 2. So it's a very nice formula. So whenever you're asked to solve, don't need to waste like this, just a proof. We just use this formula, makes it very easy. Thank you.